Okay, here's a couple of the problems from area between curves. I'm going to do two of them, 25 and 26. 25 has the following functions, f of x and g of x. I'm going to start with sketching a graph. So when I look at this first function, f of x, I know it's a parabola. And I see the x-intercepts, which would come from setting this equal to 0, are going to be at x equals 0 and x equals negative 2. I know it's going to open up. I know that, let's see, that's x equals 0, x equals negative 2. So when I go to sketch this, I know it's going to go through at 0, 0, and I know it's going to go through at negative 2, 0. I know its vertex is going to be at negative 1, negative 1, by using opposite of b over 2a. Negative 2 divided by 2 is negative 1. Then I plug negative 1 into f of x to get negative 1. So there's my vertex. So I'm going to sketch that and end up with this parabola. Then I know that g of x is a line. It goes through at 2, has a slope of 1. So I went down 1 over 1, down 1 over 1. And I know it goes like this. And if I extend this parabola, so I know this line and this parabola intersect each other. And I'm going to find those intersections by setting these two functions equal to each other. And I end up with x squared plus x minus 2 equals 0, which factors into x plus 2 and x minus 1. So I get that these two functions will intersect at x equals negative 2 and at 1. Here's the intersection x equals negative 2, and at x equals 1, here's the other intersection. So here is the region I'm finding the area of. So I'm going to integrate from let, which will be negative 2, to the right, which is 1. The top always comes from my linear function, minus my bottom, which is the parabola. And there's the integration problem. I'm going to simplify this algebra first, so I end up with the simplified integration negative 2 to 1 of negative x squared minus x plus 2, which gives me negative x cubed over 3 minus x squared over 2 plus 2x, and I need to evaluate that from negative 2 to 1. I plug in 1 first, and I end up with negative 1/3 minus 1/2 plus 2 minus what I get when I plug in negative 2, I get 8/3 minus 2 minus 4, and I do all that math and I get 27 over 6, which reduces to 9/2. The next I'm going to do is number 26. And number 26 was the two functions f of x equals negative x squared plus 9/2 x plus 1, and g of x, which equals 1/2 x plus 1. parabola opening down in a line. So I'm going to start with a sketch. And for this first parabola, I know that it goes through at 0, 1. I know the line goes through at 0, 1. I'm going to find where else these two functions are equal. By setting them equal to each other. So I move everything onto one side, and I end up with negative x squared plus 4x equals 0. So I end up with the solutions x equals 0 and 4. So at x equals 0, I now go through 1. At x equals 4, the parabola is going to give me, let's see, 1, 2, 3, 4. Let's do the line first. At x equals 4, I'm going to end up with 1, 2, 3. So there's my line. And the parabola, I know it's opening down. I know that if I check any values in between here, like for example if I put in 2, it's going to be above this line. So I really didn't make a real accurate graph, I just kind of went up. And I realized that I was looking at a region like this, where the line was the bottom, the curve was the top. So I integrated from 0 to 4. Negative x squared plus 9/2 x plus 1, the top, minus the bottom, which is the line. I simplify and do the algebra here, so I end up with 0 to 4 of negative x squared plus 4x. And I think you guys have noticed that this simplified equation that you integrate always ends up being the equation that you get when you set the two equal to each other and solve. So now I end up with negative x cubed over 3 plus 2x squared. And I'm evaluating that from 0 to 4. I plug in 4 and I get negative 64 thirds plus 32 minus what I get when I plug in 0, which is 0. And I end up with 32 thirds. Done.